Hello everyone! In this video, I will talk about ApicoAP Complete Suite. I'll first go through a short presentation to explain what ApicoAP Complete Suite, or in short ApicoAP CS, is all about. Then I'll demonstrate the use of the client software, which you can find via this page. My demonstration will be on Windows 7 operating system, but this software can be used on any platform, including Mac operating systems. First few steps that I'll go through that has to do with running the software will have to be replaced by similar steps on a Mac PC. You can refer to the user manual for the details involved. And the user manual is right here under Wiki link. ApicoAP CS depends on a machine learning model called ApicoAP. ApicoAP is a model for training classifiers that identifies apico+ targeted proteins that use bipartite signaling mechanism. I'll call these proteins in short ApicoTPs. ApicoAP model takes a positive and a negative training set containing proteins from a single apicomplexan species, say X, and it generates a classifier that identifies ApicoTPs from proteins of this species, X. More information on ApicoAP and the ApicoAP software can be found at this link. ApicoAP CS implements the ApicoAP pipeline, which includes an automated train data gathering procedure where user input is welcome but not necessary. The generated train data is then used to train classifiers that can identify putative apico+ targeted proteins from the proteins of the interested apicomplexan species. In this train data gathering procedure, the idea is to use seed training sets containing proteins whose localization in the cell is confirmed by experimental findings. ApiLoc database lists such apicomplexan proteins, but since this database is not often updated, user is urged to make a literature search to see if there are any experimental confirmation papers that came out, say, in the last year. ApicoAP model requires a training set to include proteins from a single species of apicomplexa. Since there may not be enough experimentally confirmed protein localizations available for a single species, this pipeline suggests performing an ortholog search in the protein set or the proteome of the species to identify proteins that are orthologous to one of the seed set members. After this step, the resulting set contains either proteins with experimentally verified localizations that qualifies them to be in the positive or in the negative set, or proteins that are orthologous to one such protein. This set is subjected to a filtering step where the requirement of containing signal peptide is enforced. And lastly, a subset of the resulting set that share no more than 60% sequence similarity are outputted as the final training sets. ApicoAP CS client software enables user interaction with ApicoAP CS, which is actually implemented as a collection of web services. This software is located right at this page, and now I'll show you how to download it, run it, and use it. Let's start by downloading the software. You can simply come to the downloads page and click to the latest version of the software. Let's right click here and say Save Link As to download the file to a preferred location. I'm gonna select desktop here and save. Okay. Since this is a compressed file, we need to right click and say extract all, and it's gonna extract the contents right under this folder. So before running the software, I will show you where you can find the required dependencies of the software. So it is under the wiki page, and a file named ApicoAP CS UserManual has this information. Python version 2.7 is required, which can be found under this link, and also 2 external libraries should be installed, and here are the install instructions. Okay, let's start this software. You need a command line window to do that, and you can search for it with the keyword cmd. Here you see we are under the path C users Gökçen, and we want to go further into the desktop and ApicoAP CS v1. So we are gonna do it with the command cd and desktop. I'm using tab to autocomplete after typing a couple of letters, and ApicoAP CS version 1. Alright, let's stir to see if we are under the right location, and we are. So I'm gonna type the command Python and give the program file name, which is supposed to be ApicoAP CS _client _GUI, which stands for graphical user interface, and .py. Okay, let's enter. Here is the initial window of the software, where you select the apicomplexan species you're interested in. I'm gonna select Babesia bovis for now, and you can either use the available seed sets that are extracted from the current version of ApicoAP database, and also from the current literature as of May 2013. And you also have the option to add data to the available seeds, which I will demonstrate later. So for now, I'm gonna choose use available seed set option. Let's generate training data. For the species that are already listed in the box here, it will take less than 10 seconds to complete this process, since many required files are already cached in the server. You also have the Proteome option of selecting Other here, and then submit your own Proteome file if it's not listed in this list box, and in that case you will see this operation will take up to half an hour. Now that the training data generation is complete, we can review the seed sets and the training sets that are used and generated in this process. So let's start with the seed sets. Here you can see the creation logs and the details of the positive and the negative seed set. You can see that 93 positive records and 401 negative seed records are used. And also from this log file, you can see the details. For example, the 75 of the positive set comes from ApiLog database, and 18 of them comes from current literature search that we have performed in May 2013. Alright, so you can, as you can see, there are the save to file options for each file. Let's save the negative set, for example, for our reference. Let's call it the seed negative set. Since this is a tab delimited file, I'm gonna give the extension tab. Alright, let's look at this file using a text editor. As you have already seen there are 401 records. Let's say for some reason I want to get rid of some of these records. I don't want them to be used as seed training set. So let's say I get rid of these arbitrary number of records here. Now there are 363. Let's save this guy and then go back to our window. And let's load that file to our system. It was on the desktop, and let's do that. Okay. Once we do that, we can see there are now 363 negative records. Let's say for some reason you regretted doing that and you want to reload the original file. You can always do that with the help of this button. I'm gonna go back to the main window, and then now let's review the training sets. Okay, again you see a log file summarizing what has been done to reach to this training set. And you see here there are 18 Babesia proteins that are thought to be ApicoAP targeted, and that's why they're in the positive set. And now in the negative set you see 30 again Babesia proteins that are thought to be non-ApicoAP proteins. Let's go back to the main window and let's start our training process. Here are some of the parameters you may want to set before starting the classifier training operation. Training involves an optimization procedure conducted via a genetic algorithm, in short GA. Essentially, the purpose of this training is to find the classifier that will perform the best job of identifying ApicoTPs, which involves a search in the space of all possible classifiers according to ApicoAP model. Stopping condition for the search process is determined by the GA convergence parameter. Default value is set as 30. Higher values may increase the possibility of finding better solutions, but this promise comes with the cost of increased execution time. Since each optimization run has the potential to miss the best possible solution, it is common practice to make a couple of reruns. GA rerun amount determines this amount. Again, higher values may lead to better solutions, but with the cost of increased execution time. Due to the randomized nature of this optimization and the performance assessment process we used, called cross-validation, starting with different seeds may result in slightly different results. Seeds are required by the pseudo-random number generation routine. By the way, this seed has nothing to do with the seed set I told you about before. So as I said, seeds are required by the pseudo-random generation routine, and they are usually positive integers. Users are advised to note down the GA seed parameter for future reference if they choose to change the default value from 1. I'm gonna now change the convergence parameter to 2 and the rerun amount to 1. Essentially to reduce the execution time for demonstration purposes. We use these 30 and 10 default values while reporting results in the paper, so you are advised to use them as they are initially set, or if you like higher values would also be okay. Classifier training may take up to an hour with the default parameters. With this reduced parameter set, it won't take that long. Let's start the process. As you see, the messages that comes from the server are shown to you right here, and as you can see now it is finished, and you see what's the accuracy of the generated classifier over the training set. And if you this classifier is already applied over the proteins of Babesia that contain signal peptide, and you can see them from this view predictions link. And as you see, some of them are predicted to be non-ApicoTPs and some of them are predicted to be ApicoTPs. If you like, you can save these predictions for your reference. Let's go back to the main window. And also, if you like, you can save the classifier, the generated classifier. This classifier file should be named with extension .rules for proper integration with the ApicoAP software. The classifiers you create with ApicoAP CS can be integrated with the new version of ApicoAP software version 3. This software is essentially an interpreter of ApicoTP classifiers and enables you to run them over arbitrary protein sequences. Let's save this classifier on the desktop for now. Let's call it bbovis 2, and let's name it with the extension rules. And now I'm gonna show you how to integrate this new classifier of yours with the new version of ApicoAP software. This is the page where you can find ApicoAP. Just like in the case of ApicoAP CS, you need to go to the downloads page and then get the latest version, which is the version 3 of the software. This version comes with 14 classifier definitions, and it is extendable with the classifiers you generate with ApicoAP CS. I already downloaded this software. It is right here, and again, it was a compressed file. I extracted it, and as you can see, there's a rules directory, and under it there are 14 rule files. One of them is actually the Bovisia classifier, and if we wanna add our second version of Bovisia classifier here, let's try it like this. I copied the file under rules directory, and let me show you this. So if you open this already available Bovisia rule file with a text editor, you see that the species name is set as b.bovis. And if you check your own newly generated classifier, you see that the species name is the same. So this is the keyword ApicoAP is gonna use to show you what classifiers are available. So if this is the alternative classifiers you wanna see, you need to name it differently than the original one. So I'm gonna name it bbovis 2. Okay. So the only thing I did is to place this new rule file right under rules directory. So now I'm gonna open this ApicoAP software for you to see that the new classifier is automatically available for your use. So I need to open a command line window, and I'm gonna use a shortcut here. Shift right click opens this menu, and you just say open command window here, where you save to use the cd command to come down here. So Python ApicoAP, again we want the GUI. As you can see, there are the 14 classifiers that already comes with ApicoAP, and now you have your own classifier ready for your use. And lastly, I'm going to show you how you can input or submit your own proteome and what the interface will look like when you do that. So here you need to choose the other option, where you need to input two things. One is the species name, which is supposed to be a two-word name like Bovisia, bovis, or Plasmodium falciparum. And also you need to input a proteome file, meaning all the proteins of this species. Perhaps this is a new species which is not listed right here. By the way, this list comes from UPetDB, and you have this file which lists all the proteins of the species. And this file is supposed to be in a FASTA format, but we accept only a special FASTA format, which I can show you right here. So as you know, the FASTA has the description line and the sequence lines. You see here sequence in one line. It doesn't have to be that way. But the description line should only have the protein ID information and nothing else. Normally that's not a restriction a FASTA file has, but that's the restriction we have. Okay, and if you choose, for example, the add data to available seeds option, you will be prompted to enter either a positive list or a negative list, or both, whatever you choose. So here it says positive instance list file. So list file is a special format of ours, and let me show you an example list file. So this is a tab delimited file, and the first line should be the title, and the title should contain certain keywords for us to understand. For example, identification is a keyword ApicoAP CS understands. Organism is another keyword. Description and reason. These are the all keywords we know what to do. Identification is the only required one, and these are case sensitive, so they should be written exactly like this. And each line after the title line should contain one record, and for example, the identification and the organism name should be separated from each other using the tab, not space, tab. Alright. And you only need to actually have the identification information here. You don't need to have these properties. Okay. I hope this is all for you to get started. If you have any questions, you can reach me from this email address. Thank you for listening, and enjoy the use of ApicoAP CS.